Welcome back. In our last session, we looked at archive log mode and why it's so important for Oracle recoverability. Now we're taking the next step into RMAN, Oracle Recovery Manager. Today, we are not going deep into backups command yet. Instead, we are going to understand how RMAN is built, the major components involved, and how they work together. Once you understand the architecture, RMAN commands will make a lot more sense. Let us get started. First, what exactly is RMAN? RMAN stands for Recovery Manager. It is Oracle's native tool for database backup and recovery. With RMAN, we can back up and recover things like database, data file, control file, and archive review logs. But there's something that makes RMAN especially useful. RMAN is database aware. It understands Oracle database structure and can work with the database at the block level. So RMAN isn't simply copying files. It understands what is backing up and how those backups can be used for recovery. So why not just copy Oracle files using the operating system? This is where RMAN becomes different. An operating system backup basically sees files. RMAN understands Oracle blocks, data files, archive redo, control files, and backup metadata. RMAN also tracks information about the backups and can detect certain types of corruption during backup operations. So instead of simply saying, here are some data files, RMAN understands those files in the context of the Oracle database, and that makes it much more powerful for backup and recovery. Now let's look at RMAN architecture. Here we have the RMAN Client. This is where the DBA issues RMAN command. The RMAN Client connects to the database, that is the database we are backing up or recovering. The target database has its control file, which contains important RMAN metadata. We can also have an optional recovery catalog. Then we have channels, which perform the backup work and connect RMAN to the backup storage. So our basic picture is RMAN Client, target database, channels, backup storage. And the control files and optional recovery catalog provides backup metadata. Let's start with the RMAN client. This is essentially the interface between the DBA and RMAN. This is where we issue our commands. The RMAN client then sends our backup or recovery instruction to the database. But here is an important point. The RMAN client does not store the backup data. Its role is to control and coordinate the operation. The actual backup work is performed through RMAN channels. Next, we have the target database. This is simply the Oracle database we are trying to protect or recover. It is the source of the database data we are backing up. RMAN connects to the target database and works with the Oracle server processes to perform backup and recovery operation. So remember, target database means the database being backed up or recovered. Without that connection, RMAN cannot perform normal target database backup or recovery operation. Now let's talk about the control file. The control file is extremely important to RMAN because it stores backup metadata. This includes information about backup history, backup pieces, backup location, archive logs, and other recovery related information. Think about it this way. You have the actual backup, but you also need information that helps RMAN understand what the backup is and where it is. That's where the metadata becomes important. And this is also why protecting the control file is so important when we are designing an RMAN recovery strategy. RMAN also has another option for storing backup metadata, the recovery catalog. Unlike the control file, the recovery catalog is stored in a separate database. It can contain a long history of backup information and can provide centralized management for multiple databases. And there is one important word here, optional. You can use RMAN without a recovery catalog. But in the environment where multiple databases need centralized backup metadata management, the recovery catalog can be very useful. Now we get to another important RMAN component, channels. A channel represents a connection through which RMAN performs backup and recovery work. For example, we can have channels working with disk storage. We can also have channels working with tape storage. Another important purpose of channel is control parallelism. In other words, we can use multiple channels to perform backup operations concurrently. So when you hear RMAN channels, think the connection that performs the backup or recovery work. RMAN can also create different types of backup representation. The first is a backup set. A backup set is managed by RMAN and consists of one or more backup pieces. RMAN can also compress backup sets. Then we have an image copy. An image copy is an exact bit-by-bit copy of a data file. So the simple distinction is backup sets, RMAN, manage backup pieces. Image set, exact copy of the data files. Both can be useful depending on the backup and recovery strategy you are using. Now let's put all of these components together. What actually happens when we perform an RMAN backup? First, we connect to the database. Then RMAN reads the available backup metadata. Next, we allocate channels. Those channels perform the backup work by reading the required database blocks. The backup data is then written to the selected backup storage. And finally, RMAN updates its metadata with information about the backup. So the flow is connect, read metadata, allocate channels, read blocks, write backup, update metadata. That's the basic RMAN backup workflow. Now let's look at the other side, recovery. When recovery is required, RMAN first identifies the backup needed for the recovery operation. It then restores the necessary data files. After that, the required redo and undo information is applied to bring the database towards the required recovery points. The goal is simple. Take the database from a damaged or missing state and bring it back to a consistent operational state. So RMAN is not just about creating backups. It's equally important when those backups need to be used for recovery. So why do we need to understand all of this architecture? because when something goes wrong, you need to know where to look. Imagine your backup fails. Is the problem with the channel, the storage, the database, the control file, or perhaps the recovery catalog? Understanding the architecture helps you identify which component is involved, and that means you can troubleshoot backup failures, understand performance issue, and carry out recovery operation much more confidently. That's why RMAN architecture isn't just theory, it's practical DBA knowledge. Let's bring everything together. RMAN is Oracle Backup and Recovery Framework. The RMAN Client is where the DBA issue command. The target database is the database we are protecting. The control file store important backup metadata. The recovery catalog is an optional repository for RMAN metadata. Channel perform the backup and recovery work. And finally, the backup data is written to storage. Once you understand how these components connect and work together, you are ready for the next step, actually using RMAN. In the next lessons, we'll start moving from RMAN architecture into practical RMAN backup operations. Thanks for watching. Don't forget to like, subscribe, and let me know in the comment section which DBA topic you'd like to see next. I will see you in the next lesson.